Thank you for being here. I would like to welcome you to our DVM student session this afternoon. My name is PRRSV, and I am an associate professor in the swine group at the University of Minnesota. So this is our 7th year that we put together the Morrison Swine Innovator Prize, for which our students this afternoon are competing. So I know there's some tension in the room, some stress, so I'll keep my introduction really brief, but in a nutshell, students have sent abstracts that have been reviewed by our internal team, and the people you're going to see this afternoon are our 7 finalists. They all receive a stipend and also a copy of the disease of swine to help them in their studies, and they are all competing for the 5,000 prize. So like I said, we have 7 people, and Erin is going to start this afternoon. So this is Erin Larsen from Lincoln Memorial, and she's going to talk about sparkling new solutions to long-term problems in the agricultural workforce. Here we go. Erin, the floor is yours.
Wonderful, thank you. Hello, everyone. My name is Erin Larsen. I'm a second-year vet student at Lincoln Memorial University in Harrogate, Tennessee. Today, I will be talking to you about sparking new solutions to long-term problems in the agricultural workforce. So, as we know, attracting and retaining animal caretakers is one of the most pressing issues the United States swine industry currently faces. Turnover rates among these animal caretakers is reported to be between 20 and 35%. And these high turnover rates can be very costly in terms of biosecurity, compliance, animal health, productivity, and overall morale. Last year, a survey was conducted, and the previous study found that 2 of 10 managed sow farms had uncharacteristically low employee turnover rates in the last 5 years. And the primary question was, why? Is this related to overall job satisfaction? So ultimately, their results yielded interpersonal connections matter. The individuals on the farms valued reliability, dependability, and teamwork overall. So this year, we wanted to edit and reevaluate this survey and provide quantitative results for these employee satisfaction and retention. We also wanted to find and identify areas of improvement on these farms and continue to progress in combating the industry's labor shortage and improving satisfaction overall. We also conducted a technology survey, and so that outlined the perceptions of record-keeping management systems on these farms, specifically noted as pig flow. Our survey consisted of 16 multiple-choice questions. These questions were on a Likert scale, and we also included 3 open-ended questions where farm staff were able to input whatever they felt was necessary. These questions covered areas such as job satisfaction, interpersonal relationships with their coworkers, as well as their managers and supervisors, compensation and benefits, and overall growth potential that they felt on the farm. Similarly, the technology survey had 5 multiple-choice questions on a Likert scale and 3 open-ended questions. These covered topics such as productivity, satisfaction with the application overall, and training that was used to implement this system on the farm. These surveys were emailed to farm managers, and the managers were encouraged to implement them at a time that was convenient for the farm staff, such as during their lunch period. They were also encouraged to leave the room during the implementation of the survey so as to not bias the results. These were offered in both English and Spanish to accommodate for native languages for the employees on the farm, and we administered these to 12 managed farms, of which we received 11 responses. All surveys were received prior to the deadline, which told us that they want to give us their feedback. The technology survey was also administered in a similar manner, but only given to the 4 farms that currently use this management technology on the farm. This slide outlines the average turnover rates of the farms that we collected our surveys from. The left side in green outlined the lower turnover rates, and the higher turnover rates in red on the right. All subsequent slides will follow a similar structure, where the lowest turnover is outlined in green and the highest turnover in red. We also wanted to evaluate the overall question score by the farm. So as I mentioned, these were evaluated on a Likert scale. A response of strongly disagree was given a score of 1, and strongly agree was given a score of 4, and the averages are outlined here. You may notice that there aren't very many outliers, either high or low, in terms of these scores. So what that tells us is that the numeric values may not be the best way to evaluate this data. We found that the open-ended responses were where we found the most impactful results, and I will go over those later in this presentation. These next 2 slides outline overall job satisfaction with no specific pinpoints. Again, you may notice that there are no outliers, either high or low, on both of these slides. So we wanted to focus more on specific points of job satisfaction. The first being interpersonal relationships between coworkers. What's notable on this slide is Farm 8 in red. Farm 8 has one of the higher turnover rates and one of the lower scores in terms of interpersonal connections between coworkers. We wanted to know why, what was going on in this farm that led to a decrease in score between last year and this year's results, as well as a lower score in comparison to the other farms. Upon investigation, we found that this farm has had several interpersonal communication breakdowns between multiple groups on the farm. They also have had several health challenges that have impacted communication between employees. So going forward, we will work to improve communication on this farm and make deliberate hiring and firing decisions in order to boost morale. This next slide outlines interpersonal relationships between supervisors and employees. Again, you may notice that farm number 2 on this slide, as well as this one, scored amongst the lowest of all farms. Again, we investigated why. Farm number 2 has had several managerial personnel breakdowns, turnover, and construction, as well as health challenges that have impacted their communication on the farm. So again, this is an area of improvement for us, and we will continue looking into this in the future. The next slide looks at overall compensation and benefits. Unsurprisingly, everyone wants to be paid a little bit better. But what's more notable on this slide is question number 13, in reference to the work-life balance. You may notice that farm number 6 in the orange is a little bit lower than the other farms. Upon looking into this, we found that farm number 6 is a batch farrow farm. It's possible that at the time of the administration of this survey, work-life balance was a little unattainable just due to the workload on the farm, due to being a batch farrow farm. The next slides go into overall growth potential and the interest of working in the area of interest on the farm. So we can see that the scores varied a lot between the farms in terms of achieving overall career goals. We want to continue investigating this, and this will be implemented in future reviews for each farm staff, and we will look into asking them, where do you want to work on this farm, and how do you see yourself growing here? But good news. Everyone felt that a personal commitment to improving food security and the human-animal bond was very important. This is notable because we want to know that the work that we're putting in for our farm employees and the work that's occurring on the farm is made a forefront. And we know that the animals are made a priority in all the work that we do. This slide outlines the solutions the results for the technology survey. I do want to point out that the minimums on each of the graphs is a 3. That means all of our feedback was relatively positive. Because it was all positive, we wanted to look into the open-ended responses to pinpoint the areas of improvement for the technology survey specifically. Going into those results, for the job satisfaction survey, we felt that it was important to combine all of these results into a word cloud, because this highlights the words that were most frequently used amongst all of the survey responses. You may notice that everything, the environment, the animals, and teamwork are some of the notable words here. We also wanted to highlight the improvements made by, or the points of improvement noted by the farm staff. Unsurprisingly, salary and pay are highlighted there, but also the ability to learn, training, and the team are words that stand out to me. So to outline the 6 takeaways that were most frequently noted in the free response. Personal accountability and upholding accountability for coworkers was one of the most frequent responses we received, as well as knowing deliberate hiring and firing decisions in order to boost morale and get the right people on the farm. Allowing freedom to learn, placing a higher value on communication in a native language, and providing translation services was also very important. And the employees wanted to receive more feedback and accessibility to resources to do their jobs effectively. For the tech survey, we found that the first 3 bullet points were positives that we received in terms of this application. They noted labor efficiency, communication with their team, and improvements on attending farrowings and improved production in the farrowing house. We're able to save more pigs. The bottom 3 bullet points need to be recognized if you are going to integrate this system on a farm. The ability to integrate with other record-keeping apps and other technologies in order to maximize its efficiency. Having a strong internet signal is necessary for the implementation on a farm, and it requires reliable training and support in order to be successful. So, what now? We understand that this feedback is very important, and it addresses ways to improve the largest areas of opportunity on the farms. We want to implement this survey again in approximately 1 year to reevaluate the status of farm staff satisfaction and retention, as well as consider transitioning to an approach that helps us gather more individualized, open-ended results, because that's what we have found to be most beneficial here. We want to highlight that implementing these surveys in the native languages is very important for us to receive that feedback and be able to communicate with effectively. These are links or QR codes to the direct surveys that we used. Feel free to scan them, and you may use them on your own farms and edit them as needed. And I just want to thank Suiday Health and Production, as well as the Leman Conference and sponsors, for the ability to be here today. Thank you so much.
Do we have questions for Erin?
Examples of the technology?
Yes, good question. So the technology that was used on these farms specifically was pig flow.
Okay.
Thanks. Did you make any observations on the production efficiencies in the farm in comparison to some of the salary result or some of the survey results?
Yeah, that's a great question. I think that's a wonderful area for opportunity where we can go in and look at the production results. We did not specifically with this study.
I have one more question. I looked at overall the graph, and it looks like farm 9 and 10 were in dark red, but it looks like their scores were actually pretty high. And so I was wondering if you could comment on that.
Yeah, so do you have a reference as far as any particular variable?
No, it means like overall their score is pretty good. So I was just wondering if you were investigating as far as why, or if you had any hypothesis maybe.
Sure. So yeah, that's a great point. I did not really think about as far as why. We didn't really fully investigate the impacts as to why, but being on those farms and talking with the employees and getting their surveys from them, it felt that they really did have a high job satisfaction, and potentially their high turnover rates could have been due to just personnel changes and changes in lifestyle. So thank you.
Additional questions? No? Thank you, Erin.
Do I carry this?
Right, so our next speaker this afternoon is Valeria Lugo from the Universidad Nacional de Colombia. And her presentation is survival of 5 strains of PRRS in tap water at 3 different temperatures.
Okay, so good afternoon, everyone. My name is Valeria Lugo. I am indeed from the National University of Colombia. I'm a last year vet student, and I'll be presenting this study I carried out as part of my internship here at the University of Minnesota. It's a comparative study on the survival of 5 different strains of PRRS virus in tap water at 3 different temperatures. So, to give a little bit of a background, as I'm sure we're all aware, the PRRS, porcine reproductive and respiratory syndrome, is the disease that causes really high economic losses to the swine production industry. And as we know, there is a seasonal occurrence of the disease, mostly in the winter. So we also know that for the transmission, there are indirect routes. If we were to consider some of the environmental sources for this virus, we could ask ourselves about water. But what will we have to take into account? The fact that for it to be like a considerable source of the virus would have to itself survive for long enough and in high enough concentrations to actually infect the pigs. So regarding this question, there is scarce information. There's a couple studies regarding water, city water, well water, and also some evaluating swine slurry. What have we seen? Mostly these studies evaluate a single strain, but there seems to be like a trend of having longer virus survival at colder temperatures. So setting this background, the objective, as the title said, we plan to determine the time to survival of the different strains of the PRRS virus in tap water at different temperatures. How did we do this? So first of all, the virus stock had to be grown. We had to have the different strains. Which strains did we choose? So we had these two, the VR2332 and NMN 3100 as reference strains. We also had the Lelystad virus as part of the PRRSV1 genotype, and the 174L1A and 144L1C, as these have been involved in the major outbreaks in recent years. These strains were all grown in the Mark 145 cell line. Then for the water, we took the water from a lab faucet. It was, as the title suggests, it's tap water. Now for the treatments, we did these treatments to do a comparison between, to see if there was a difference between having chlorinated versus non-chlorinated water, because as we know, tap water has some low levels of chlorination. So we had just the tap water, then we also had tap water where we added sodium thiosulfate as a dechlorinating agent at 30 milligrams per liter. Then we also autoclaved simple tap water, and we autoclaved water that had been dechlorinated. These methods as type of sterilization. Then, to prepare the samples that we were going to evaluate through time, we took 3.75 milliliters of the different water treatments, and we mixed them with 0.75 milliliters of each virus solution. We had triplicates, meaning that there was a triplicate for each combination of each viral strain per each water treatment at each temperature. What were the temperatures? So we evaluated the survival at 37 degrees, the samples placed in a rack, the triplicates, and then when they were placed in an incubator for this temperature. Then for room temperature, which varied between 21 to 23 degrees, they were just placed on a lab bench. And then at 4 degrees, they were placed inside a refrigerator. Then to carry out the sampling, at each sampling point, we collected 0.5 milliliters of each sample. We carried out serial tenfold dilutions in 96-well plates. And then we did the titration to find out the viral titers based on the appearance of cytopathic effect on the cells on the Mark 145 cell line. And then we calculated the titers, and they're expressed as TCID 50 per 100 microliters. What were the sampling times for each temperature? We can see here, for 4 degrees, we did it at 0 hours, and then 24 hours, 3 days, and then up to 35 days. Then for the room temperature, it was the same, just about up to 3 weeks. And for 37 degrees Celsius being the highest temperature, we did a closer intervals for the sampling up to 24 hours. And the viral titers, as I said, were expressed in a TCID50. What were the results? So in this graph, bear with me, I know there's a lot. I'm going to be showing you the different water treatments that I used. And as we can see here on this y-axis, we can see the viral titers that express a TCID50 and a log scale. And on the x-axis, there is time. For 4 degrees, it's expressed in days. For for room temperature, it's also expressed in days. And 37 degrees, it's in hours, given the sampling times that I showed previously. So, oh, and here we have the different strains that were used. So for 4 degrees, all the different strains, they made it up to 35 days. At 35 days, we still had detectable titers. Perhaps they could have made it longer if we were to have done further sampling. For 21 degrees Celsius, this ranged from about 3 to 7 days. 7 days being the longest for this reference strain, the VR2332. And then at 37 degrees, as kind of expected, they only made it up to a couple hours, ranging for 8 hours to about 16 hours. There was one that actually made it to 24 hours, again being the 2332 strain. Perhaps it could have made it longer, but that was not tested. And these are the results that we got for just the tap water. Then, when comparing with the tap water that was autoclaved, the results were basically the same. 4 degrees, it also made it to 35 days. At room temperature ranging for 3 to 7 days again, most of them 3 to 5 days. 37 degrees, again, from 8 to 24 hours. As you can see here again, the VR2332 was the one that made it to the longest time. For the water that was dechlorinated with sodium thiosulfate, again, we can see the graphs have a little bit of noise, but we can see the trends. At 4 degrees, it was still up to 35 days, perhaps even longer. For the room temperature, it was about 3 to 7 days, excuse me. And then 37 degrees, again, 8 to 24 hours. For the dechlorinated water that was autoclaved, we see similar trends. Once again, not to repeat myself, 35 days, 3 to 7 days, and 8 to 24 hours. If we were to evaluate, to compare the titers that we had at the start of the sampling times and the ones that we had at the last sampling time where I could detect the viral titer, we can see once again for this reference strain, the VR2332, it had the lowest reduction percentages, ranging from, as you can see here, at 4 degrees, it had only been about 20% for all the water treatments. This one is about 40%, but it was way lower compared to the others, which range from 50 to 70%. Then, if we were to evaluate room temperature, once again, the VR3332, it was the one with the lowest percentage of reduction at 7 days, which was the longest. The others range from 50 to 70%. Again, that was from 3 to 5 days, which was not as long as the other one. And then at 37 degrees, there was about a 60 to 70% reduction percentage. Again, this one is in hours compared to the days at room temperature and 4 degrees. What are some of the key limitations that I want to show with this presentation? The fact that the starting titers, like the amount of virus that we had for all the treatments, all the viruses, were not the same. They range from about 10 to 4.5 to 5.5 TCID50, but that's to take into account. Also, the tap water, it may not be representative of what happens in the field, of the field conditions with what we have in the farms. The chlorine levels themselves were not tested, so I did not have control over that variable. And then also to take into account that some strains perhaps are better adapted to cell culture. But what we can take away from this is the fact that we did see a marked effect on temperature and the virus survival. As you saw, at 4 degrees, the virus remained quite stable, up to 35 days. However, regarding the water treatments of chlorinated versus dechlorinated, it was very similar. As you saw also, the strain VR2332 perhaps seem to survive longer than the other strains. This is not based still on a statistical analysis. It has not been carried out, but it's a trend that we can tend to see. And also the fact, a final conclusion, this virus may be stable for prolonged periods of time in water, especially at colder temperatures. So it's something that may be taken into account when controlling disease outbreaks. And therefore, I would like to acknowledge the people here listed and the Swine Disease Eradication Center for funding this study.
Questions for Valeria?
How did you decide on your sampling time points, especially considering they were different between the treatments?
Yeah, it was mostly based on previous literature. We saw that it was reported that colder temperatures, it would probably survive longer. So there we are like, okay, so 4 degrees we'll probably have to do it the longest, up to a month. It was 35 days. And then the other two, 37 degrees is really high. So that's why you saw that the intervals were way lower, and actually like only one of them made it to 24 hours. We weren't really expecting any of them to make it past 24 hours. So that's why we did like shorter intervals for that one. As well as room temperature, it wasn't gonna probably make it as long as 4 degrees. So we just decreased it a little bit, 2 weeks. But it was mostly based on what was previously reported.
Question?
So thanks for that. I just wanted to clarify then the sodium thiosulfate did not have you didn't see a significantly higher log reduction with that.
Yeah.
And so that, I'm curious, we had done some similar work a while back. We use a modified live vaccine for this. Just sodium thiosulfate is a common ingredient in disinfectant neutralizing broth. And our concern was that it was the neutralizing broth was having activity against the virus. And we found that it did. Sodium thiosulfate actually appeared to be a pretty good pseudo-disinfectant for PRRS virus. I'm curious though, again, we used the vaccine. Do you have any theories about why you didn't see infect than we did maybe?
Yeah, actually, I did have a bit of a problem with the sodium thiosulfate at the start. I was seeing that it was tending to have the virus tended to survive for shorter times, but when I repeated it, it didn't show again. So I thought it was maybe more of a mistake with the experiment itself, because I did this like twice, and the second time I did not see the lower survival times. Perhaps there was a sodium thiosulfate itself, but I wouldn't be sure.
Other questions? No? Thank you, Valeria. All right, our next speaker is Lauren Harper, and she's going to talk about exploring the use of ultrasonography at palpable landmarks on sows to measure and track body composition.
Okay. All right, so today I'm going to talk about my work that I did this summer at Michigan State University under the advice of Dr. Madonna Benjamin and with the help of Savannah Thompson, who is a first-year vet student at MSU. Okay, so first I'd like to explain why we chose to study the use of ultrasonography to better understand sow body condition. Sows are replaced on farm, and it's important to make a solid, sorry, I had notes and now they're not here. So to make a solid balance of adding new genetics through gilts and replace it, but keeping the higher producing older sows. And it's our belief that if we're able to better monitor their body condition, we are preventing overspending on feed and not gaining any benefits to underfeeding and seeing problems in health and reproductive success. Okay. So some of the top reasons for sow replacement is failure to return to estrus, failure to rebreed after one or several breedings, and low farrowing and weaning performances, which may all be traced back to a low body condition score. So we hypothesize that if we can better understand sow body condition score, then we can perhaps increase the protective life of sows. And despite the importance of measuring and monitoring sow body condition, some of the techniques used on farm are bias, not repeatable between observers, and based on moderate correlations to actual carcass weights. Some include visual body condition scoring and using the body caliper at the last rib. So overall, our objective for this project, and this project is just the first step, hopefully, in continuation of creating a system that could monitor each individual sow's body condition and change throughout lactation without the use of farm staff monitoring, and use it monitor with computer vision. So the first objective was to be able to show that ultrasonography can be repeatable and reliable multiple days in a row, and also between observers. And we wanted to use see if different locations could also be repeatable than the traditional 10th rib and last rib back fat and loin-eye area, to better correlate with future computer vision systems. After that, we would take the repeatable measures from the first objective and track sows throughout an entire lactation and see if we could trend the different changes with change in body condition score or weight or other industry standards, such as last rib total back fat. So on to objective 1, where we were trying to establish repeatability and reliability between observers. Here's some of the locations that we chose. We chose our locations based on easily identifiable landmarks and easily palpable landmarks. So the green circles represent current industry standards, the last rib, total back fat, loin-eye area, 10th rib, and the blue circles are the new proposed locations that we looked at. So I'll go through each of those real quick. So the first was the tail. We chose the flexion of the tail, and at this easily identifiable site, we approximate that it was about the level of the 5th caudal vertebrae. And here's an image of a sow that just finished weaning and with very little fat on top of her 5th caudal vertebrae, compared to a sow that was going off on the truck for coal. And here's us scanning at that location. Then we have the neck, and this is at the flexion of the neck if they raise their neck. And we approximate this to be the level of the 1st thoracic vertebrae. And here's what it looks like on ultrasound. You can see the spinous process down below, and we measured to that depth. And here we are scanning at that location. Then we also included industry standards to be able to compare to. And here's an image representative of our measurements. We measured each of the different layers and the loin-eye area. And we also did cross-sectional measurements to estimate marbling at the loin-eye at above the 10th rib. 2 other locations was the palpable shoulder landmark and the wing of the ilium that we could palpate as well. Here's approximately where those are on the skeleton. And this is what the shoulder looked like on ultrasound and the wing of the ilium, and we measured to the highest point. Here we are measuring those 2 areas. And you did have to rock the ultrasound back and forth to try to find the actual highest measure, and then we would take it from there. We also looked at abdomen and the last rib just distal to the loini area, and then measured to that last rib there and to the peritoneum at the abdomen, at the flank, right in front of the patella. Some other industry standards that we used to compare to also were height, weight, body condition score, caliper, and flank to flank. And here we are taking the caliper at the hip, and we used hip and shoulder as new caliper landmarks to see if those were also correlated with the last rib. So here's our results. These are ANOVAs comparing me and Savannah. Ideally, we weren't supposed to have any significant differences between us because we were measuring the same things on the same animals for 3 days in a row. But we found differences at the last rib, innermost layer of back fat, and the peritoneum. And for the last rib, innermost layer, we attributed this to a very small distance that we were measuring and the insensitivity of the ultrasound that we were using with finger tracing to try to get that distance. So there was already some error in that, and since it's such a small measure, being off by 1 millimeter there was really significant. And then the peritoneum moved a lot. We watched it move while the sow was grunting, the abdomen flexed, and it changed the depth. And whenever there was GI contractions, that changed the depth of the peritoneum too. So here were some of our excellent reliabilities over 0.9 interclass correlation coefficients between both of me and Savannah, and then good, which is over 0.75. And I wanted to point out these three, the 10th rib, back fat, last rib, middle back fat, and neck, because they were also consistent and excellent reliable markers within each observer. So we compared intra and inter reliabilities for those. So that was objective 1. Objective 2 was then to take those markers and then measure them weekly throughout a lactation of a sow from pre-farrowing all the way through weaning. And I just wanted to point out some trials and tribulations of that area, trying to climb over the cages, using positive reinforcement to let the sows, get them to let us measure them. We also used marshmallows and trying to fight off the piglets while they were trying to attack our equipment. So there's that. Some of our positive correlations to industry standards, we're still in the process of going through the data at this point, but this is some preliminary work that we found. We found good correlations with industry standards, last rib total back fat and 10th rib total back fat at the shoulder, ilium, and moderate at the neck. And we also looked at the effect of weak for the ultrasound measurements and the effect of parity comparing gilts to parity 2+. We found that gilts had lower last rib and hip measurements, lower flank score, flank to flank, weight estimates, height estimates, weight, and 10th rib longissimus dorsi area. And weak was, or caliper at the hip was also affected the measurements week by week, and also the 10th rib back fat and last rib back fat, different measurements. So we found a strong correlation between the hip and the last rib total back fat measurements. So this could be an alternative site for ultrasounding to understand body condition score in sows. And it's more accessible in some of the farms at the farm that we were at, because you're at the back end of the sow often. And it had a strong correlation if you just looked at the first measurement pre-farrow and the last measurement at weaning. And then I wanted to point out that in gilts, we used the hip caliper, and this is a comparison of last rib to last rib body caliper, the industry standard, to last rib total back fat. But in gilts, we found a better correlation at the hip. So potentially understanding body condition score in gilts, you might want to use the caliper at the hip instead of the last rib, and it's more accessible. In sows, it was about the same. It was the body caliper at the rib was was better than the body caliper at the hip. And I wanted to show our ultrasound measurements across the board over the weeks were significantly different week by week, but we didn't find significant differences in weight, flank to flank, weight estimates, and height. And obviously height, they didn't change too much. And we propose that the change in weight that you see here, mostly at right following farrowing, the passing of the babies and the placenta, but then it was counterbalanced by mammary development and milk production, so the overall change in weight was not different, and therefore weight is not a great idea for monitoring sow body condition. And there's a representative graph of 10th rib total back fat, and it's changed by week. As you can see, it trends down, and we're going to look further into each of our different measurements and how they're affected by lactation and potentially correlate to where the sow is moving fat first. And future directions, again, are to be able to use this information and with computer vision and try to correlate our ultrasound measurements to what the computer can see and not have to use farm hands to understand sow body condition.
Any questions for Lauren?
Yeah. Oh.
Hi, did you look at time comparisons as far as going for using a caliper versus ultrasound?
As you mean week to week over the lactation?
Yeah, like how long did it take you to actually go through and use the ultrasound versus a caliper?
Yeah, we were getting really good towards the end of the summer. In the beginning with Objective 1, it was taking us a while. There was definitely a training period. I had a little more experience than Savannah, and I had to train her how to use it. But towards the end of the summer, we were scanning the sows within less than 5 minutes, and that included putting booties on and getting into the cage, to the bearing and everything.
Nice presentation. My first question, I have two questions. My first question is, did you take a scientific approach to look at the marshmallows as the treatment modality? And did you consider others such as Oreo cookies, which some of us have found have worked much more effectively?
We did actually. The marshmallows were just a lot cheaper, especially if you got the mini ones, so we went with the cheaper option.
My real question is kind of a follow-up. Did you use the variable of how long it took or ease to take the measurement as a feature in your comparison at all? And did you calculate that comparison across the other measures?
Yeah, we haven't looked at that yet, but we did, luckily with the ultrasound, it recorded time points for every ultrasound scan that we did. So we do have the time between each sow and also the time for each scan of each location. So we can look into that.
Other question? I actually have one, Lauren. So I know you're still processing some of the data, but as far you looked at a lot of different methods and areas of the sow, which one do you think is most promising as an alternative to what we're doing right now?
I think the hip is the most promising location now just because of the ease of access. It has a pretty strong correlation to last rib back fat, and obviously some work still needs to be done in comparing it to actual carcass values. And the shoulder, it was a little more difficult, like logistically, to get into there with the farrowing crates and if they're leaning against it one way or the other. And the neck was a little difficult in getting repeatable measurements depending on where their head was located. We tried to keep them in a neutral position, but obviously that was a little difficult. The marshmallows definitely helped to keep them where we wanted them.
All right. Thank you.
Thanks.
Thank you very much, Lauren. Right. Our next speaker is Casondra Snow from the University of Minnesota, talking about minimizing sample cross-contamination for the detection of Mycoplasma hyopneumoniae.
Hi, I'm Casondra Snow, and I graduated this past spring from the University of Minnesota with a bachelor's in animal science. And I'm a current first-year DVM student at the U, where I was admitted through the Veterinary Food Animal Scholars track. I've been working with the Mycoplasma Research Laboratory for about 2 years now, where I've been given the opportunity to conduct research and present it here today. So let's talk about minimizing sample cross-contamination for the detection of Mycoplasma hyopneumoniae. So to begin, what is Mycoplasma hyopneumoniae? Well, it's a bacteria that causes respiratory disease in swine, and it lives mostly in the mucosal secretions of the lower respiratory tract, but it can be found throughout the entire respiratory system. And it's crucial to collect samples for diagnostic testing of Mycoplasma in order to decide on a management plan. These samples are typically collected with deep tracheal catheters, as they are found to be the most sensitive to diagnostic testing. And as you can see, it requires a lot of materials to be in the pig's mouth or make contact with the catheter in some way, allowing for a lot of potential cross-contamination between the samples. So cross-contamination is really common with sample collection, and that leads to misleading diagnostic results. It has been found that DNA is very robust and resistant to environmental degradation, and so some sort of disinfection needs to occur in order for that DNA to go away so that you don't get the cross-contamination. But disinfection of materials between sample collections is not something that has previously been standardized for Mycoplasma hyopneumoniae. So with this study, we aim to compare various disinfecting compounds on their ability to minimize sample cross-contamination in swine tracheal secretion collection. So a quick overview of what we really did in this study was we contaminated the materials with the Mycoplasma hyopneumoniae strain 232 in 2 different ways, artificial and natural contamination, which will be further explained in the coming slides. And after contamination, but prior to disinfecting, we collected samples from those materials and then disinfected them with various wipes and collected post-disinfecting samples, and then extracted the DNA on all of these samples and performed PCR to determine the prevalence of genetic material. So for the artificial contamination method, we used the Mycoplasma hyopneumoniae strain 232 culture that was diluted to a 110 dilution, and it had a starting CT of just below 17. And that was put into a syringe with a nasal atomizer in order to spray the material sets. And we had 6 different material sets that involved a laryngoscope blade, a mouth speculum, and a pair of scissors, as these are the common materials used to collect tracheal secretions with deep tracheal catheters in pigs. After spraying, the materials were left to dry for 2 hours underneath the biosafety hood. For the natural contamination method, we collected tracheal secretions from 30 nursery-age pigs that had been previously inoculated with Mycoplasma hyopneumoniae strain 232 for a prior experiment. And we used 6 material sets again, including a laryngoscope blade and a mouth speculum and a pair of scissors. Each material set was used on 5 different pigs to ensure the contamination of the materials. And this image is just an example of deep tracheal catheter collection. It is not from our study. So both the artificial and natural contamination methods were swabbed within 5 hours after contamination. And then they were disinfected in the exact same way with various wipes for approximately 10 seconds each. And the wipes that we used were the alkyl dimethyl benzyl ammonium chloride, or a quaternary ammonium-based wipe that is commercially available, and an alcohol-based wipe, a bleach-based wipe, and 2 different commercially available brands of hydrogen peroxide-based wipes. We also used a phosphate-buffered saline wipe for a control. And we collected from the top of the blade of the laryngoscope, the rungs of the mouth speculum, and the inside of 1 blade of the scissors for each collection. After disinfecting, the materials were sprayed with distilled water and then wiped down with a PBS-soaked wipe. For both the natural and artificial contamination methods, we extracted the DNA from the pre-disinfecting samples, the disinfecting wipes, and the post-disinfecting samples using a automated magnetic bead extraction system. And then species-specific PCR was performed with a real-time PCR to obtain a CT value for each sample. Data analysis was then conducted in the program R with Kruskal-Wallis test to determine any statistically significant differences, between the samples. So, all of these materials that were used, the mouth speculum, laryngoscope blade, and the scissors, were made from stainless steel. So we took the CT value of each one, which is seen on the y-axis, and then the materials along the x-axis down here. For artificial contamination, we found that there was no statistical difference between these materials, so we were able to use them as replicates within each treatment. And we did the same for natural contamination. Again, no statistical difference was found, so they could also be used as replicates within the treatments, and this allowed for more data points to be within the treatments and more accurate results. So for the artificial contamination method, which again was the cultured spray, prior to disinfecting, we found here the CT value along the y-axis and the treatments along the x-axis. The CT values were very similar to begin with CTs between 24 and 29. And then post-disinfecting, those CT values were raised, meaning that some genetic material had been removed, but not all, except for with the bleach-based treatment. The bleach-based treatment had a CT value above 40, implying a negative PCR result, meaning there was no genetic material left on those materials. For the natural contamination method, which again was the deep tracheal catheter collection event, prior to disinfecting, we saw a wider range of CT values between 27 and 38, with CT again on the y-axis and the treatments on the x-axis. But still no statistical difference between these treatments. And after disinfecting, again, we see that bleach resulted in negative PCR results. And one of the hydrogen peroxide brands also gave a negative PCR result, which this is likely due to the higher starting CT value of hydrogen peroxide brand A, seen here, than there was in the artificial contamination method, meaning there was less genetic material to be removed from those materials for that treatment. So, to summarize these results, there was no statistical difference between the individual materials within each treatment group, and the treatments prior to disinfecting were not statistically different either, with both contamination methods. Bleach was the only treatment that resulted in the complete decontamination of the materials in the artificial contamination method. And bleach and hydrogen peroxide brand A were both, they both resulted in a complete decontamination of the materials for the natural contamination method. So some limitations of this study were that we did have a relatively small sample size. Even with combining the materials within each treatment, there was still very few data points. And it is important to note that we were looking at decontamination by removing the genetic material rather than the bactericidal effects that a lot of these treatments likely do have. So similar studies have been done in the past on disinfection of other pathogens, such as PRRS virus, but this is the first study to our knowledge that has investigated decontamination of Mycoplasma hyopneumoniae. So because of the small sample size and the fact that this is the first study in this area, further research is necessary for more definitive results. But this study can be used as a jumping off point for further research into the decontamination of Mycoplasma hyopneumoniae protocol that could be used in production facilities. So some take-home points here are that not using a disinfecting agent will likely result in cross-contamination, as the PBS-based wipe that we used did not remove genetic material sufficiently, meaning that rinsing with just water or wiping the materials down with water would not be enough to minimize the potential for the cross-contamination. And bleach was the best way to decontaminate the materials, as bleach was the only disinfectant that resulted in the removal of all Mycoplasma hyopneumoniae genetic material for both artificial and natural contamination methods. So I'd like to acknowledge Cassidy Corden for her help with the natural contamination method, the Mycolab team for continuous support in various ways throughout the entire process, and the Swine Disease Eradication Center for sponsoring this project. Thank you.
Questions for Casondra?
Hi. Thank you for your presentation. So what percentage of bleach did you use for the contamination?
Yes, we use 10% bleach.
Thank you.
This will probably be answered in a follow-up study, but if you were to hypothesize based off of your initial results, what do you think that using bleach to disinfect your equipment between pigs could potentially have a residue that would increase your number of false negatives?
That is a very interesting question that would need to have further research in order to answer effectively. But I suppose, well, we rinsed them afterwards with water, so I would think that the bleach that was put on there would get rinsed off with that. But there is, I suppose, potential for false negatives if you're using bleach. But I would think that the catheter itself would have enough on there that your bleach on your materials would not affect that too much.
Additional questions? No. Thank you, Cassandra. Our next speaker is Carly Bates from Iowa State University, talking to us about how low should the pH go.
Yes, thank you for the introduction. Hello and good afternoon, everybody. My name is Carly Bates. I am a current third-year student at the Iowa State College of Veterinary Medicine. And this summer, I got a lot of opportunities to spend time in barns and at sites that were unfortunately dealing with E. coli breaks. So that really led me to wanting to focus one of my summer projects on the prevention or the decrease of E. coli as it becomes more of a problem in our swine industry today. So this is my project, How Low Should the pH Go?, looking at how the pH level affects growth of E. coli. So just a little bit of an introduction. E. coli is a gram-negative bacteria that is commonly found in the lower intestines of pigs. E. coli does interrupt the intestinal barrier, which can lead to enterotoxemia, diarrhea, or even sudden death. And it is one of the leading causes of morbidity and mortality in recently weaned pigs. So, due to the increase of morbidity and mortality, E. coli ultimately costs producers money, which nobody likes. Currently in the swine industry today, there are many antimicrobial resistant E. coli strains, making it very difficult to treat once we have a break. We also want to focus on treating or preventing on a whole herd level due to the decrease of labor that we see in the industry today, rather than treating on an individual pig basis. We also want to be able to focus on prevention versus intervention. So we typically know when flows or when certain sites deal with E. coli breaks that they typically happen over and over, so being able to prevent them before they happen as opposed to intervening and treating after they occur. So there are many products that are currently being utilized to decrease E. coli outbreaks without the use of antimicrobials, and one of which is being acidifying products. So these acidifying products are typically cheaper and fairly easy to use, but the question still remains is what is the actual pH that we should be targeting? So it is very common on farms to hear, oh, get the pH somewhere between 4 or 5, but is this truly the level that we need to be targeting? So this leads me to the objective of this study, which is to determine the growth levels of E. coli at varying pH levels. So this study was completed in 2 phases. The first phase was to reach the target pH of the media without contamination, and the second phase was to grow the E. coli at these varying pH levels. So diving into phase 1, I took 88% lactic acid and mixed that with sterile water at a 1 to 10 dilution to create a stock solution. From there, this stock was added into 100 milliliters of tryptic soy in increments anywhere from 0.05 milliliters to 2 milliliters until a pH of 3, 4, 5, 6, and 7 were met, and then this was confirmed using a calibrated pH meter. So what I would do is just draw up small amounts of that stock solution, add it into the test it with a pH meter, read the pH, and then from there add more as I needed to get to each of the pH levels. So this picture just shows, they're a little hard to see, but getting to the pH of 3, 4, and 5, just as a demonstration, and this was completed on media that was not used in the actual test to avoid contamination. And then this chart shows all of the final amounts of the lactic acid stock solution that was added in order to reach all of the pH levels. So as you can see, to get to a pH level of 7, I only had to add 0.35 milliliters of the stock solution, whereas to get all the way down to a pH of 3, I had to add 17.25 milliliters of the stock solution. So then moving on to phase 2 of this study, once the desired pHs from the levels that were found in phase 1, those were all reproduced in individual tryptic soy broth containers, again getting to the pH of 3, 4, 5, 6, and 7. From there, 1 colony of E. coli was then obtained on an inoculating loop. It was placed in the tryptic soy broth and swirled vigorously, and then all of these vials were incubated. And there also was a tryptic soy broth without lactic acid that was utilized in this study as a control. So then from there, once all of these vials were incubated for 24 hours, they were then diluted using 4.5 milliliters of sterile water and 0.5 milliliters of the inoculum, and they were diluted all the way from a 1 to 10 to a 1 to 100,000 dilution. These dilutions, as well as the original inoculums, were then plated using 4.5 milliliters of the solution spread evenly over a 5% bovine blood agar plate using an inoculation loop. These plates were then incubated and evaluated after 12 hours. So moving on to results of this study, the tryptic soy broth inoculums at a pH of 5, 6, and 7 were visually cloudy, whereas at a pH of 3 and 4, they were still pretty clear and you could see through them. All plates at a pH of 5, 6, and 7 had very noticeable surface growth, whereas plates at a pH of 3 and 4 had no visual surface growth. And then at the 1 to 100,000 dilution, a pH of 5 had 398 colonies of surface growth, where a pH of 6 and 7 had too numerous colonies to count, which could potentially be indicating that there is a mild inhibition of growth that does begin near a pH of 5. So this is just comparing all of the broth inoculums at the 24-hour mark of incubation. So as you can see, at a pH of 3 and 4, they were still pretty clear. You can still see through them, whereas a pH of 5, 6, 7, as well as the negative control were pretty cloudy. You couldn't see through them, and this is potentially indicating growth occurring within these vials. So then moving on to the 1 to 1,000 dilution, this is all of the plates. So as you can see, there is growth on 4 out of the 6 plates. So at a pH of 3 and 4, there was no visual surface growth, where at a pH of 5, 6, 7, and again, as well as the negative control, all had pretty significant growth, and there is a pretty significant cutoff between the pH of 4 and 5. So then this is also at the 1 to 1,000 dilution, and this is comparing the highest pH to the lowest pH. So again, 3 having no surface growth, whereas a pH of 7 having pretty significant surface growth. And this just provides the proof that there is a benefit to acidifying E. coli's environment to inhibit or prevent the growth of E. coli. Again, this is at the 1 to 1,000 dilution, and this is comparing a pH of 4 and a pH of 5. So there's no surface growth on 4 and pretty significant growth on 5. And this comparison just really helps us to really dive in on a certain target level that we should be targeting for pH environments to decrease or prevent the growth of E. coli. So we know from this comparison that there is a pretty significant cutoff between the values of a pH of 4 and a pH of 5. So then moving on to the dilution of 1 to 100,000, a pH of 5 had 398 colonies of surface growth, whereas a pH of 6 and 7 had too numerous colonies to count. They had well over 500 colonies of growth, which is outside the suitable counting range and not affecting the growth of E. coli. So this can indicate that there is a mild inhibition of growth that does begin near a pH of 5 for E. coli. So just some discussion within this trial is there are many acidifying products that are currently on the market and available for producers to use. So we really want to make sure that we are using these acidifying products correctly in order to see the most benefit and in order to reach these target pH levels. We should be encouraging producers to test and check pH levels of water, especially if the site or the flow has a history of E. coli. So although this was an in vitro study, we still know that getting that pH to a lower pH or getting to that target level can help decrease or prevent E. coli growth. So some limitations within this study is the addition of lactic acid stock solution does increase the volume of the tryptic soy broth vials, and this could have affected the concentration. So further investigation would be needed to determine if this did affect the growth of E. coli at all. And then visual growth is a subjective measure, and visual growth was used in order to get results from this study, but it is still a valuable representation in order to compare the growth of E. coli at these varying pH levels. So just some next steps within this study. One of the next steps would be to understand E. coli's growth inhibition at pHs incrementally from 4 to 5. So we know that there's a pretty significant cutoff when looking at a pH of 4 and a pH of 5, but really diving in and seeing where in between those two pHs is the actual cutoff. And then another step of this project would be to gain an understanding of an in vivo enteric luminal pHs when pigs are administered water at these various pHs. So really taking this study on farm, using it in pigs to see how the effects would be there. So in conclusion, how low should the pH go? We know from this study that the pH should go to the pH should be 4 or lower in order to see a decrease of E. coli growth. We do know that there is a pretty significant and clear cutoff between a pH of 4 and a pH of 5 in the growth of E. coli. And if you are unable to reach the target level, we know that the lower the pH can go, the less growth that is seen. So I would like to give a big thank you to Dr. Rachel Sticka-Jensen, Dr. Cameron Schmidt, and Dr. Emily McDowell at Pipestone for all of their hard work, as well as all of the wonderful Leman sponsors. I will now open the floor to any questions that anyone may have.
Thank you, Carly. We have one question here. Microphone is coming.
Is this an F18 E. coli that you cultured?
Yeah, so the question was asking if this was an F18 strain of E. coli that was cultured. It was. It was F18, and it was from a clinical case that we had found previous in the summer.
Okay. And I'm not sure if this is on.
It is.
Okay.
It is.
All right. I'll take your word for it. From a application standpoint, we're looking at that 4 or lower pH being the one that's inhibitory for E. coli growth. Do you know if there's anything in the literature that suggests it's a lower threshold for water intake? As if you push that acidity too far, do we run the risk of limiting water intake in those susceptible nursery pigs?
Yeah, so the question is asking if lowering the pH would affect the water intake of pigs. Unfortunately, I did not do or look deep enough into the literature to know how that would affect the pigs on farm or in their water intake, but that would definitely be in future studies of this project.
Carly, congratulations for your talk. How is the minimal time of incubation to kill the E. coli? I saw that you incubate for 24 hours, but did you evaluate a minimal time of period to kill the bacteria? And did you test the same protocol for another bacteria like Streptococcus suis or something like that?
Yeah, so the question was asking about the incubation time that was chosen for the E. coli growth. We did use 24 hours, and that was just a a time period that I kind of chose, knowing the growth of E. coli and looking at previous studies and how it, the time that it needs to grow. So that was just something that I chose, but I got that from previous research.
Did you do any other bacteria? I think that was.
Oh,
part of the
yes,
question.
sorry. And then the next question was if there was any other studies done on any of other bacteria. And unfortunately, there was not, but that would definitely be future studies that would be able to utilize with this project as well.
I have another question. Did you check the pH after the incubation?
Sorry, could you repeat that?
Did you check the pH after the 12-hour incubation?
Yeah, so the question was if the pH was checked after the 12 hours of incubation, and it was not because we wanted to avoid contamination. It was just checked previous to the tryptic soy broth being inoculated with the E. coli.
No more questions? Thank you, Carly.
Thank you.
All right, our next speaker is Hope Dolman from the Iowa State University, talking to us about the evaluation of an absorbent mat for swine disease surveillance in weaning-age pig.
Well, good afternoon. My name is Hope Dolman. I'm a current third-year student at veterinary medicine at Iowa State University. And this summer, I had the opportunity to work with Carthage Veterinary Service to evaluate the use of an absorbent mat for swine disease surveillance in wean-age pigs. Now, wean-age pig samples serve an important role in the swine industry as they're commonly used as a surveillance tool for assessing herd status and progression in disease elimination programs on the sow farm level. Now, with the amazing research that has been conducted lately, there's many other options that extend beyond weaned piglet sera to use as sampling types. However, the similar challenge presents for many of these sample types, which is the need for additional time for training as well as labor on the sow farm. So with this challenge, it presents the need, which is the need for efficient weaned pig samples that require little time, skills, or labor needed on the sow farms. Ideally, a new sample type would be great if it could test for multiple different pathogens, including PRRS, PED, Lawsonia intracellularis, and much more. This study actually surveils diseases entering or exiting farms through passive surveillance in loadout chutes, which leads to the objective of this study, which is to analyze the level of detection of PRRS, PED, and Lawsonia intracellularis genetic material in wean-age piglets through the use of an absorbent mat. Now, the sampling treatment used for this study was a pig blue absorbent mat pad. Now, contrary to the name, this was not created with use of indication in swine facilities. It's actually commonly used in surgery suites, auto mechanic shops, and other areas where a high absorbency mat is needed. Now, for this study, we knew that this mat needed to be durable, especially since it was going to be an area of high traffic. So maybe not in the most scientific way, we tested the durability by putting the mat in with a group of gilts, allowed them to explore the mat, and remove the mat. When we analyzed it prior to, or after that, we found that the mat was quite soiled. However, there were no rips, tears, or holes. So it proved to be a durable sampling treatment for this study. This study was conducted at a 5,600 head sow farm in Illinois. It had previously tested positive for PRRS in March of 2023, and this study was conducted this summer in 2023. 6 randomly allocated weaned pig loads were selected for this study, with a range of piglets per load ranging anywhere from 1,000 piglets to 1,600 piglets per load. And for this study, a sample event refers to a single loadout event. Now for the study design, to start, 400 mils of distilled water was added to the mat to soak the mat. The mat was then placed in the chute, as you can see here, about in the middle of the chute, and the location of the mat remained the same for all 6 of the loads. The pigs were then allowed to cross the mat following standard loadout procedures for this farm. And then once the load was completed, the mat was collected and fluids were expressed into conical tubes. The samples were then submitted to an external laboratory to test for PRRS,
PED, and Lawsonia intracellularis using a ddPCR test. Now I know ddPCR tests may not be very commonly used in the swine industry, so I'm going to take a moment to just give a very simple and very brief overview of the difference of the tests. So ddPCR, otherwise known as a digital droplet PCR, is a high dividing test providing high precision results. One of the main differences is quantification, seeing that a ddPCR gives absolute quantification compared to that of a real-time PCR. A ddPCR also detects genome edit rather than genome expression, and its results are reported in copies per microliter compared to a CT value of a real-time PCR. Now, for the ddPCR copies per microliter, a higher number of copies per microliter refers to a higher number of genetic material found within the test. This chart shows the copies per microliter values for the PRRS, PED, and Lawsonia detection with the ddPCR results using the absorbent mat. As you can see, all three of the pathogens were detected at low prevalence through the use of the absorbent mat. Now, this may not be great for you to analyze, seeing that most things are in CT values, so the results from this ddPCR test were extrapolated into a real-time PCR test to provide CT results. This chart shows the CT values for PRRS, PED, and Lawsonia detection after that extrapolation. Now, I know what you all are probably thinking. All of these values are over 40, so this is what your report would really look like, seeing that all of these may be negative. However, a big thing to keep in mind for these results is that this was through an extrapolation. These results were not originally ran through a real-time PCR. We took the results from the ddPCR, ran them through extrapolation for these results. This table shows the average results of both tests reporting in their respective value. So overall, this pilot study, through using the absorbent mat, found that there was detection of swine pathogens at a low prevalence. In conclusion, this pilot study, through using the absorbent mat, was able to detect swine pathogens at low prevalence. And if you remember what I talked about at the beginning of the presentation, I said the goal was to limit the time, skills, labor, and to be able to detect multiple pathogens. This passive sampling method did all of those, even if it was detecting at low prevalence. There were some limitations with the design, the first being that there may have been a dilution factor from added water to the mat, resulting in different sample results. It also served as an indirect surveillance sample, seeing that the piglets were shedding the disease into the environment and the mat was then picking it up through the loadout chute. There may have also been some sample loss during hoof impact as the piglets crossed the mat. And another question is this really a piglet sample or is it an environmental sample, seeing that the mat was placed on the floor of the loadout chute? And then for farm health status, this is only a PRRS positive farm. But this leads to future work and many research opportunities using this mat. One could be to fine-tune the amount of liquid needed to extract the mat sample and whether that liquid needs to be added prior to loadout or after loadout. Also using different liquid medias to test the efficacy of the sample, as well as testing incoming animals or testing different age groups of animals as well. For the test, using the ddPCR and the results that I showed you, the CT values were based off of extrapolation, so those might not be completely accurate CT values as if this was ran through a real-time PCR test to start. However, for future work, of course, that can be something added to a next research project, and these results may show that there may be future use using the ddPCR in future swine sampling projects. So how can you take this information out and use this? The pig blue absorbent mat did show to be a durable tool that can be used to collect swine samples in the industry. This sample could be explored for environmental testing use, or it could have potential use in surveillance or elimination programs in farms. These results also show that the ddPCR is a highly sensitive test that picks up virus at very low levels. I would like to thank Dr. Claire LaFay with Carthage Veterinary Service and Chris Taylor and Kartik Kakre with the SHIELD T3 team for all their help on this project. I'll now open the floor to any questions.
Questions for Hope?
Hi, excellent presentation, so congrats. My question, I have several, but the more pressing one, can you elaborate on the extraction protocol of the mat? My point being, depending on how you guys did it, I'm curious if you normalized the sample by the DNA concentration going into the digital PCR, or if you did it by volume, or via mass of the mat.
Yeah, so the question was about extrapolation of the sample. I can't give you the best information for that since it was done at an external laboratory and analyzed by an external company. But just to give some more information on how the sample was taken once it was removed from the chute, it was placed in a bag, Ziploc gloves were used, and then extracted into the different tubes, and then it was frozen prior to being sent out. And then the difference between the results from the ddPCR and the real-time PCR, the extrapolation there was based on a equation based on curves that were obtained from CT values compared to those copies per microliter values.
Hi, great presentation. Just to get an idea of the best comparison, I assume other surveillance testing was being performed at this farm. What CT values were you seeing from that testing?
Yeah, so the question was CT values seeing already tested on the farm. I don't know the exact CT values, but weekly surveillance testing was occurring on the farm. And there are CT values, I think, maybe around 25, 27, that were signifying that the PRRS was still present on this farm.
There's one more question here.
Was there any animal handling challenges with now having a strange item in the chute?
So the question was any animal handling issues. So I did not help with the loadout since they wanted to keep it as a standard loadout procedure, but I did talk to those individuals who were completing the loadout, and they said if anything, the piglets stopped to sniff at it, but the loading was normal. There was no holdup in the time.
Yeah, hi. I'm curious to know the reasoning behind selecting the chute as a sample point rather than, say, a wean hallway.
Yeah, so the question was basing if you were selecting the chute over a wean hallway. The chute was selected because normal farm procedures were still happening within the hallway that the wean pigs were in waiting to be loaded. And so we didn't want any interference with boots or tools or anything to be interfering with the mat, which is why the chute was selected, because we knew the only thing crossing that mat would be the piglets.
Thank you very much, Hope. So our next presenter is Sarah Lutz from Auburn University, talking about the pharmacokinetics of ceftiofur crystalline free acid in the first hour after a single dose IM administration in swine.
Thank you. Good afternoon. My name is Sarah Lutz, and I'm a third year at Auburn University. Today I will be presenting on the pharmacokinetics of ceftiofur crystalline free acid in the first hour after single dose intramuscular administration in swine. During my summer internship, I had the opportunity to complete 2 research projects, one of which I'm about to present, and the other that you can catch me presenting at ASV in 2024. During my internship, I also had the opportunity to go on several herd visits with my mentor, Dr. Doug Powers. I took advantage of our windshield time to discuss diseases of different age pigs, including diagnosis, treatment, and control strategies. One disease we discussed was Streptococcus suis, which is currently rising in prevalence. This graph shows the % of cases with a strep suis diagnosis at Iowa State University's Veterinary Diagnostic Lab from 2008 to 2021. In 2020 and 2021, 1 out of every 5 cases, or 20% of cases submitted, had a strep suis diagnosis. This was up from less than 10% of cases in 2017. So as you can imagine, Strep suis is high on the priority list of many producers and practitioners today. There are several factors that practitioners base decisions on when selecting an antibiotic to treat a disease like Strep suis. Antibiotic selection factors include labeled pathogens, clinical breakpoints and MIC values, ease of implementation, and withdrawal times. Duration of therapy is another important factor to consider, especially with today's challenges in labor. In a perfect world, cost wouldn't be a selection factor, but in reality, cost is one of the key selection factors for practitioners and producers. Exceed for swine is one option for the treatment of Strep suis. Exceed is also known as ceftiofur crystalline free acid, and it is labeled for the treatment and control of swine respiratory disease associated with Actinobacillus pleuropneumoniae, Pasteurella multocida, Haemophilus parasuis, and Streptococcus suis. Exceed is known for its long duration of therapy, staying at therapeutic plasma levels for at least 7 days. Minimum inhibitory concentrations, or MIC values, are important to consider when selecting effective antibiotic treatments. MIC 90 is the antibiotic concentration at which 90% of labeled or bacterial isolates are inhibited. In 2022, Sweeney et al. Published a new MIC 90 for Strep suis at 2 micrograms per milliliter. This is the previously published pharmacokinetics data for the plasma concentrations of ceftiofur crystalline free acid and its active metabolites. The plasma concentration is displayed on the y-axis with hours on the x-axis. The solid line shows the plasma concentration of ceftiofur crystalline free acid and its metabolites in micrograms per milliliters for 7 days. The dotted line is at 2 micrograms per milliliter, which is the MIC 90 for Strep suis. While the existing data displays the long duration of therapy for Exceed, the first data point measured was at 1 hour post-injection. Plasma concentrations at 1 hour were 2.23 micrograms per milliliter, which is greater than the MIC 90 for Strep suis at 2 micrograms per milliliter, as indicated by the reference line. The pharmacokinetics of Exceed at time periods less than 1 hour post-injection are unknown, so it is unclear when plasma concentrations of Exceed will surpass MIC 90 levels for labeled pathogens. The objective of my study was to understand the pharmacokinetics of ceftiofur crystalline free acid in the first hour after a single intramuscular dose in swine. For the materials and methods, 3 barrows and 3 gilts for a total of 6 weaned-age pigs were weighed and enrolled into my study. A dose of 1 milliliter per 44 pounds was calculated for each pig in accordance with the swine label for Exceed. Blood was collected immediately prior to administering an intramuscular dose of ceftiofur crystalline free acid. Blood was then collected at time points of 5, 10, 15, 30, 45, and 60 minutes post-injection for each pig. The blood was then sampled into heparinized green top tubes, spun down via centrifuge, and plasma was collected. A derivatization method in reverse phase high-performance liquid chromatography was used to determine the concentration of ceftiofur and its active metabolite in plasma. To make it easier for discussion, I will just talk about ceftiofur, but it's important to know that this test did measure ceftiofur and its active metabolite, which is often referred to as DFC. So transitioning into the results of my study, this table shows the plasma concentrations of ceftiofur at each time point. The table displays the 95% lower confidence limit, the mean, the 95% upper confidence limit, the standard deviation, and the range of plasma concentrations across the 6 pigs. If you will, let me draw your attention to the 15-minute time point. You can see that at 15 minutes, the mean plasma concentration was 2.44 micrograms per milliliter, which is greater than the MIC90 of 2 micrograms per milliliter for strep suis. Looking at this range, even the lowest pig had a plasma concentration of 1.97 micrograms per milliliter, which is pretty close to the MIC90 for strep suis. Now looking at the 30-minute time point, the mean plasma concentration was 3.83 micrograms per milliliter. The range shows that by 30 minutes, every pig had plasma concentrations levels above the MIC90 level for strep suis. This chart provides another way to visualize the same data, displaying ceftiofur concentrations for each pig at each time point. The concentration of ceftiofur and its active metabolite is shown on the y-axis, and the time points measured are displayed in minutes on the x-axis. The black dotted line represents the upper confidence limit, and the solid line represents the lower confidence limit. The orange reference line is at 2 micrograms per milliliter, indicating the MIC90 for strep suis. At 15 minutes, nearly every pig had ceftiofur plasma concentrations above 2 micrograms per milliliter, with every pig crossing this threshold by 30 minutes. So in conclusion, ceftiofur crystalline free acid achieved therapeutic plasma concentrations in all pigs by 30 minutes post-injection, with 5 out of 6 pigs reaching it by 15 minutes. So producers and practitioners can be confident that Exceed not only has a long duration of therapy, but it also reaches therapeutic concentrations rapidly. Thank you to my mentors, Dr. Micah Jansen and Dr. Doug Powers, and to the Leman Conference Planning Committee and sponsors of the Morrison Swine Innovator Prize for making today possible. Thank you. At this time, I'd like to take any questions.
Thank you, Sarah. Questions for Sarah?
Sarah, nice talk. In addition to plasma concentration of ceftiofur, did you study the concentration in lymphoid tissue, in lymph node, since ceftiofur can interfere in B cell physiology?
That was a great question. The question was asking if we also looked at concentrations in lymph nodes, and the answer was no, but that would be a great follow-up study. We only looked at concentrations in the blood or in plasma.
Oftentimes we're treating pigs that are under some sort of stress, right? Either that's at processing time or whatever. Would you theorize that there would be any differences in that information if you were looking at stressed pigs?
The question was asking if there would be any differences in information when looking at stressed pigs. And honestly, I'm not sure if cortisol levels would influence this or not. That would also be good to look into.
More question? No? Well, thank you very much, Sarah.
Thank you.
So that was our last presentation for this session. So I would like to thank you all for coming this afternoon, for our sponsor that make this, the Morrison Swine Innovator Prize possible, and also all of the veterinarians and the producers that are in the room who open their barns and to students, that take the students on their truck, and I think that's how we recruit our next generation. So thank you so much for the time and energy you put in spending your summers with our DVM student. And our next session will be in this room, the research highlights at 3 p.m. Enjoy the break. Thank you very much.